Okay, so to fit the Kubernetes way and I guess be feasible with sprawling microservices apps, storage needs to be dynamic. Like, there's no way a cluster admin or whatever can be manually provisioning volumes for pods. It just doesn't scale. Well, enter storage classes and dynamic provisioning. And they're the same thing, right? Storage classes enable dynamic provisioning of volumes. The big picture looks like this. Storage backends plugged into Kubernetes, we're all good with that, yeah? Though, the CSI is pretty new, so we'll probably be seeing in-tree plugins for a while yet. Anyway, we create one or more storage classes. And you can have as many as you want, right? But each one relates to a particular storage backend by referencing a plugin. The official term for a plugin in the YAML files is provisioner, and we'll see it in a second. So, as an example, right, if you've got a Portworx and maybe a storage OS on the back end, each one's going to have its own plugin or provisioner. And each of your storage classes that you write is going to reference one of those. Alright, well, like everything else, a storage class is an API resource, so it's defined in a YAML file. And in there, as well as referencing the provisioner, you give it a bunch of parameters. Now, some of them you'll already know, like access mode and reclaim policy. But you also give it the values that relate to stuff on the backend itself. So like, look, I don't know, if your backend supports pink fluffy SSDs or chocolate flavoured super low latency NVMe stuff, yeah? Well, you can put that in the YAML. Then you apply these storage classes to the cluster and it's business as usual. So you create your PVCs that reference a storage class name, you then reference those PVCs in pod specs, and we all live happily ever after. Brilliant. But if I have to do one more PowerPoint slide, I'll be sick. So let's have a look. I've got a YAML file here called sc.yaml, and it's in the course repo under the storage folder, and we can see it's defining two SCs, two storage classes. Now then, starting from the top, kind storage class. We've already said this, right? It's its own resource in the API. Oh, and look, it lives under the storage.kubernetes.io/v1 API group. And this is cool, right? You see, back in the early days, the Kubernetes API was a monolith, so everything was lumped under one big group called v1. But monoliths are pure evil, so the API has been broken up into groups. And storage classes here, it's a great example of a resource living in the storage API group. And it's stable now, right? Because it's in v1 of that group. Anyway, the name's important. This is how it gets referenced in PV claims. The provisioner here, this is the plugin for the backend storage. This one's for Elastic Block Store volumes on Amazon Web Services. And then we give it the parameters, which is where we tell it how to build the volumes on the back end when we ask for them. And this is a decent example. We're saying the type of EBS volume should be IO1. Now, don't worry if you don't know what that is. It's just the AWS API name for their fast SSD storage. I think its friendly name is Provisioned IOPS if you know your AWS. But you know what? You don't need to know your AWS. The point is, this is telling the storage backend something about the type of storage the SC will provision. We can tell it which AWS zones to provision from, and we're telling it in this example how many IOPS we want per gigabyte. So a 10 gig volume would be 100 IOPS, a 20 gig volume 200 IOPS, you get the picture. But again, right, the detail is not important. What is important is the fact that we can tell the backend exactly what we want. Now, of course, the backend and the plugin have to support what we're asking for, but you get the picture. And there's another one below, right? Again, for AWS EBS, but this time for the slower general purpose SSD. Oh, and we're using an annotation here to set this one as the default. Now, doing this via an annotation might change in the future, but it's how we do it for now. Now, all this detail is back-end stuff, right? And it's all hidden behind these two names. So all of this complexity, right, gets advertised on the cluster as either fast or slow. And the names are arbitrary, right? You can call them whatever you want. But when you come to request these two types of storage via a PVC, You just ask for fast or slow, or red or green, or whatever you decide to call them, yeah? Well, just one more before we move on, right? This one here is for a Portworx backend, and there's a lot going on as we can see. Obviously, we're using the Portworx provisioner, but we're being explicit about what file system we want. Block size needs to be 32K. We'll have 2 replicas, thanks. And remember, right, this is all being implemented by the Portworx on the back end, not Kubernetes. We'll have a snapshot every 30 minutes, please. Medium performance of a sort. And you know what? Let's encrypt it. Fabulous. Detail, detail, detail. But all hidden behind this friendly name. So the Kubernetes admin or whoever cares about this. The developer or app cares about this. Brill, shall we provision someone a cluster? Okay, I am on a 3-node cluster in AWS this time. And if we look at the cluster, it's got no storage classes. Well, I've got the storage class YAML from just a second ago, and it's in my working directory here. So that means I can go ahead and deploy it. Okay, if we look at storage classes again, there they are, and slow is the default. And if we describe, let's say, fast, this is what we want here, the parameters. All good, yeah? Now then, it's a clean cluster, so we shouldn't have any PVs or PVCs. Okay, well, I've got this PVC YAML as well. So naming the claim AWS Fast, making it 10 gig and basing it on the fast storage class we just deployed. Let's have it. Alright, now if we list it, it should show as bound, so already bound to a PV, and all without us manually creating a PV. Because remember, we've created the fast storage class and we've plugged it into the AWS Elastic Store backend. Then our storage class says, hey, anytime a new PV claim comes along asking for storage from me, go ahead and dynamically create it on the backend and create the PV on the cluster. Bingo! Bound. This is the PV it dynamically created, 10 gig, and from the fast storage class. Proper dynamic. And if we quickly look on the AWS backend as well, bingo, there it is. This is the name of my cluster and the PV name. 10 gig, type IO1, yeah, and 100 IOPS. Remember in the storage class we said 10 IOPS per gig. Good stuff. So, back here, if we list the PVs, roger that. Everything we'd expect. Bound to the AWS Fast claim using the fast storage class. I love it. Now, behind the scenes, right, as with all things Kubernetes, it is implemented through a control loop. So the persistent volume subsystem has a control loop constantly running and watching the API server for new PVC objects. And anytime it sees one, it actions it. And that's it. Storage classes, making Kubernetes storage dynamic and yanking it into the modern world. Now, let's go and open up the sample app and see what storage stuff we can find in there.